Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Okay, Bismillahirrahmanirrahim. Welcome to a live lesson on A-Level Maths, Pure Maths, Year 2. If you can write your name in the chat message to say that you're in the lesson and that you can see me, that would be great. This is the book we're going through. I'd recommend you get that, and you can work through that at your own pace. Try to finish every question by your exam, and you then do a few past papers and you'll be okay for the exam, inshallah. So it's Lady Khadija Online College. It's a live A-level lesson Monday to Thursday, every day 9 p.m. Year 2 at Excel. So starting off nice and easy, let's get a new page open. Today's topic is proof by contradiction. Contradiction means that two things go against each other, particularly that one looks like it's saying something and the other one is saying something else that's the opposite, so they can't both be true. So it means that if we've relied on something we thought was true to begin with, and then we've developed that and we find out that what we've ended up with is something that's false, then that's a contradiction. If what we had started with was really true, then everything would be true afterwards. And if we end up with something that's false, then we know that what we thought was true to begin with couldn't have been true. It has to be false. So that's the idea. That's the kind of contradiction that we'll see in the following example. But how does that help us prove anything? The reason it can help us prove something is if you've only got two options. So if a number can be either odd or even, and you can prove and you can show a contradiction. So imagine that you're thinking the number's odd, and then you follow through the steps and you end up with showing that no, there's something wrong here. What I'm reading in front of me has to be false. Then it means that what you started with has to be wrong as well. So if we started with assuming it was odd, then that has to be wrong, which only leaves one option, so which is even. So just by proving a contradiction when we started with odd, then we've automatically proved that the answer has to be even. So just before I carry on, let me just check that the sound is coming through. If you could just confirm in the chat window. Okay, so just keep that in mind, and what we have to prove now is that there is an odd number that is the largest odd number. There is a greatest odd number. We're going to call it an integer, meaning whole number, but we can just read it as a whole number. There is a greatest odd number, and we're going to call that n. That's what we have to prove. So how do we prove that? What we're saying is that if we follow this through, if we assume that this is true, that there is an odd number that is the greatest, let's call that n. So let's assume there is a number n which is the greatest odd number. If we assume that's true, then if we develop it and we find out that we're now reading something that looks false, then we've got a contradiction. So it means that we couldn't have had the beginning sentence as a true. So let's start with, we've got n, it's the greatest odd number possible. Well, now let's take n plus 2, let's add 2 more to that odd number. Because 2 is an even number, and we're saying that n is an odd number, then what we've got is an odd plus an even. An odd plus an even is equal to an odd. That's a result that you can rely on because you've done that in year 1, so you can assume that an even plus an even is equal to an even, an odd plus an odd is equal to an even, and an even plus an odd equals an odd. They're results from year 1, so you can take on any one of them. So we've got n, which is odd, we've got n plus 2, so that's your odd number n, plus 2, which is an even number. So we've just proved that if n was odd, by adding on 2, we've ended up with an odd. But n plus 2, because we've added 2 to it, has to be bigger than n. But that contradicts what we started with, that n is the greatest odd number. Because greatest means there's no number bigger than it, but n plus 2 is bigger than n. So therefore there is no n which is the greatest odd number. Probably not the best explanation, but you'll have to just go with it for now until I can think of a simpler one. Let's try same principle, proof by contradiction, but this time we're looking at something that's probably a bit more realistic. We're looking at, think of the squared numbers. Can we prove that if the squared number is even, then the number that made it is odd. So let's call the square number n squared. Can we prove that every time we get a square number which is even, that the number that made it, the n, is odd? So let's try using the example that if we have two options, an odd and even, if we can take away one of them, then the other one has to be true. So let's start with what the question is saying, that the number we're going to start with is odd. So if n is odd, then we can write n as 2 times some number plus 1. Okay, again, remember that from year 1, that an odd number, the even numbers can be written as multiples of 2, and the odd numbers can be written as multiples of 2, add or take away 1. So we're starting with n is odd. That means we can write it as n equals 2k plus 1. Now if we square that, and I'm just going to put n is odd, that's our assumption that we're going to think is true to begin with. And if we find out that later on we've got something that's false, then we know that our assumption is wrong. So n squared has to be 2k plus 1 squared. If I expand that out, then I get 4k squared plus 2k plus 2k. maybe just because it's the first lesson and maybe your maths is a bit rusty, let me just do that slowly. So we're doing 2k plus 1 squared. Squared means the bracket comes twice, so I can write 2k plus 1 times by 2k plus 1. That's what the squared really means. I can get rid of the squared now. So if I multiply that out, you can use any method you like, but you should get, in the end, 4k squared from the 2k times 2k plus 1 times 2k plus 1 times 2k, so that's 2k plus 2k, and then right at the end, the 1 times the 1 makes 1, so just simplify that as 4k plus 1. And then let's, the 4k squared and the 4k, I could bring 4 out to the front, but easier than that, I'm just going to bring 2 out to the front. So I've got 2k squared plus 2k plus the 1. Now why did I bring 2? Because 2 is special, because remember I said that an odd number is 2 times a number plus 1. Well, this is what we've got here. We've got 2 times a number plus 1. So if I've got just the first bit, 2 times a number, that's got to be even, because any number in the 2 times table is even. As soon as I add that 1, I've now got an odd. So this whole thing is odd. So what I've proved is that if I start with an odd number and I square it, then I'm going to end up with an odd number as the answer for the square number. So if the square number is even, n squared n is odd. No, that can't be true. N was odd, the square number was odd, so the only way I can end up with n squared to be even is that n has to be even. Okay, that's the example done, and hopefully you can join me for the next lesson tomorrow. Assalamu alaikum wa rahmatullah. Peace be with you and the blessings of God.